So yeah, thanks for coming back. For those who missed the quick introduction, we just had a 20-minute pausing slot for you to grab lunch because our speaker, Ralf Klinkenberg, unfortunately is stuck in traffic, so he will join us today, but we moved his slot to the end of the conference today, so he'll be talking at around 3:15, 3:20 with the same topic, but just for you to know why we had this pause, so this time isn't lost, but we'll just add it to the end on this stage. And now we'll continue with our next speaker. It's George Hancock from T-DAB.AI. He'll be talking about scaling AI at the edge, federated learning. He's the CGO and Business Development Director at T-DAB.AI, a data science and data engineering innovation company specializing in developing and building machine learning solutions. It's great to have you here. You have 20 minutes, so we're already excited to hear what you brought for us. Thank you very much.
Can you hear me okay on this microphone? Great. So yeah, good afternoon. I'm here today to talk about scaling AI at the edge with Federated Learning. As the compare nice introduced, my name is George Hancock, and I'm the CGO and Business Development Director at T-DAB.AI. So T-DAB.AI is enabling industry to access new markets, customers, and revenues with edge AI that is more private, cost-efficient, and resilient. And throughout my talk, I'll tell you about the problems we've encountered and solved for many of our customers, and as well as some of the case studies as part of that process. So we're all aware of the benefits of AI machine learning for industry. Now, operators of machines, operation, production, or generation of a product or service is tightly correlated to press the wrong button there, is tightly correlated to revenue, such as Industry 4.0, energy, or connected shipping. They want on-device intelligence. Now, they want on-device intelligence to predict critical events, to optimize control, to improve outputs. These are many use cases that we've seen across the machine learning and the AI space. Now, industrialists want this to increase productivity by maintaining machine uptime, detecting anomalies in advance as well. Deliver hardware as a service propositions to access new revenues, so they can actually increase that servitization of an existing product in the market. And then operate in challenging environments, so they're locations they've not been able to access before. Sorry, I think I've got a timer on here that's not quite working. Operating challenge environments, such as like an energy space, where we're distributing intelligence down to the edge. Now, the problem with centralizing IoT data for AI is that first word, the centralization of data. We have to pull hundreds and thousands of device data into a central location to be able to provide that intelligence back for the model. This is restrictive to access the value and the benefits of AIoT. Now, the three problems, the three barriers we see in terms of encountering that, firstly is privacy and security. Companies that are trying to provide this solution face a paradox. Companies are happy to buy the machines, they want the intelligence, but they're not often willing to share the data with the businesses and with other suppliers for fear of losing their competitive edge or that data being breached. And the second is the cost. Now, the cost of data transfer and storage alone is starting to ramp up. We're seeing restrictions around computer servers. Microsoft and AWS announcing those restrictions around certain clients not accessing those tenancies. And then the final one is network reliance. So the reliance on data and machine learning systems at the edge on the connectivity, and those devices not always been able to connect to the cloud. Either they're through being connected in a Faraday cage, it's like a privacy and security concern for companies, or they're truly operating at the edge, for example, like a wind turbine that's out at sea. Now, as they get further and further out, because we lose the nearshore shallow lands, we can't lay fiber cables. So it's important to bring together the total cost of ownership and the network reliance with areas like wind turbines. So we've come up with what we think is an elegant idea. So we're rethinking AI systems design for industrial IoT. So we don't move the data to the model, we move the models to the data. And we need three things to be able to do that. We need an infrastructure that spans cloud and edge. So we've got a scalable platform to do that. We need to be able to integrate a mechanism to learn without moving data from the source devices. So we need to be able to do that intelligence at the edge. And then we need a highly automated process across the machine learning process by cloud and edge as well. And this is where we introduce OctaiPipe. Now, OctaiPipe is a cross-platform, end-to-end distributed edge AI platform optimized for training, deploying, and managing models in any IoT environment. And we see this as the next generation edge AI solution. The platform itself, under the hood, is a distributed MLOps infrastructure. sorry about the loading speed of these, is a distributed MLOps infrastructure. So we can actually deploy MLOps across the cloud and edge, and that for the entire model lifecycle management. It's a platform for data scientists, by data scientists, so we want to make sure that that can actually provide not a black box solution, but the ability to integrate and utilize services that we built previously and give full transparency to that process. So for things like machine uptime, anomaly detection, we provide those prepackaged components for data scientists to use quickly and out of the box, but also give them the ability to actually integrate with their own development environments and build their own solutions to deploy across the cloud and edge as well. And so with that, we integrate with all the major libraries, and we give them the out-of-the-box solutions to be able to view the dashboard, the MLOps Health, the Data Explorer, and also with Active Directory for active user management. So it's a seamless integration into the business. But the real USP, as is the part of the talk, is with federated learning. So we federate on-device intelligence, so without removing that data. So if you think about the hundreds and thousands of devices and device data we're looking to collect, sorry about that, we can actually train the models for each of the devices. We can aggregate the model and create a central global model for that device, then redeploy it down to the edge for that intelligence. And this is where I think it might be me being too fast on the trigger here, but I'm not sure if it's the weird timing on the slides. But we can create a new global model as well that aggregates that data and can be deployed. So if you're looking to add a new device in that process, we can then deploy that intelligence seamlessly to the edge and federate that across an entire network and retrain that model and deploy it back on the devices as well. And so just a few key features of OctaiPipe. So again, we mentioned it's a platform by data scientists, for data scientists. We built that on global standards that many of the data scientists will recognize in this process, but a few key features that I do want to highlight. So the seamless edge cloud connectivity and the seamless model deployment for the cloud and the edge. The experimentation and the model management tools that are key for a data scientist and a developer in that space. So using familiar tools that they can use and quickly get up to speed with. The automated MLOps for massively scalable model lifecycle management. This is a key part. I think we've heard a lot of people today talk about the importance of MLOps, and over the last few days thinking about potentially $1 to build a machine, $100 to actually run and manage that continuously. And then the USPs are on the special federated learning capabilities. And what we're looking to do as a business is obviously deploy that down to the NUC devices on the edge and hopefully down to the bare metal as well. It gives us a massively scalable platform. So why does OctaiPipe matter? Why do we care? The first of all is accelerated AI. So we're familiar with the process of building models, the popularity on data scientists, but the real challenge is around accessing data engineers, accessing those common platforms to build and scale a platform solution seamlessly and scale that across an estate. And that's where we can deploy models and infrastructure in less than a day and get the team up and running very quickly. The next, as I've touched on, is the USP around federated intelligence, so we can learn across these hundreds and thousands of devices without centralizing the data. This in turn gives way to the privacy around AI, so where companies are concerned around sharing their data, but also people don't want to any risk around data breach or access to that data. We have the reduced data costs, so we're not actually moving the data for data storage and data compute costs, especially where there's restrictions around resources and tenancies. And then the massively automated MLOps capability, overcoming those challenges around resource access and engineering shortages and challenges. I've had a lot of conversations here today where people have said, I've offered someone a job, they've then pulled out, and then they've gone to somewhere else for twice the money in a different sector, proving it really challenging to actually resource to some of these projects. So finally, the case studies, how we've actually put this into practice. So the first one I'd like to talk about utilizes many of the models I've referenced before. So remaining useful life, machine uptime, and anomaly detection. This is where we've used many of the modules we have in OctaiPipe and the OctaiPipe platform to deploy this down to the edge for a canning manufacturer. Now, the canning manufacturer that we're working with, and this is supported by the Innovate UK program, which is a funded government body in the UK, they have about 36 factories worldwide. The benefits for these in terms of how we worked in solving them was to apply the model initially to find the results for the insight that we could predict in machine uptime. And that equated to about £3.5 million per line. There's 2 lines per factory. Just mentioned there's 36 factories worldwide. The business case quickly stacks up for them. It took 12 to 18 months to build that process out for them. And we really recognized the opportunity of building out OctaiPipe and building out the module to actually have it in a self-serve deployment mechanism. So other businesses can benefit from that much more quickly instead of waiting for that 12 to 18 month process. This is where we sort of founded OctaiPipe in this project. And so from here, what we were able to do is deliver a 5% reduction of spoilage events to predict that amount, and that's a conservative amount, and that's just on lost revenue. This also gives way to applications around energy and yield optimization as well. I think the key one from here is that we can save up to 14 million cans per day globally. The next is in energy optimization, another key use case in the sort of energy and industrial space, where we're able to use Edge AI to optimize the energy usage of HVAC devices. So currently in the HVAC process, there's some sort of rules-based system. What we're able to do is actually develop a machine learning algorithm and then apply that for deep learning and deploy that down to Linux boxes at the edge, again, using the OctaiPipe modules and framework. The federated learning use case, which is a great example of actually, I think there's one earlier about comparing federated use cases. This is a benchmark of using federated versus centralized intelligence when able to deploy that. Again, apologies for the formatting, but we could actually show that federated performance was the same and similar to a centralized process as well. If anyone would like any of the case studies and the reports around these, I'm also happy to share them afterwards. And the last one I'd just like to talk about as well is a combination of OctaiPipe and additive manufacturing. So the hydraulic pumps industry, the flow control technology, and what we're looking to do is embed OctaiPipe into these pumps as well to deploy out to the pump, valve, and control sector. And if we can, the impact of OctaiPipe and the platform here would reduce that control technology by about 60% of their CO2 emissions, which I believe is about 1,800 million megatons of CO2 a year. And again, this is tens of thousands of devices with integrated sensors. And one of the key parts of what we're able to do is actually train devices simultaneously. So instead of one application being developed and deployed in one scenario, we can actually train tens, hundreds, thousands of devices at the same time with the portal. Great, so that's actually me. What I have included on the slide is a link to a video. So if you'd like to have access to more information around the portal or on the platform and some of the case studies, you can scan the QR code and that should take you to a landing page to then access the video as well.
Thank you very much, George, for bringing these case studies and sharing what you're doing in your day-to-day work. We're pretty good on time, so we got time to answer some questions from the audience, if there are any. So there's one in the front, and please quickly say who you are and which company you're presenting.
Hi, I'm Vishal Kumar from Alice Camera. One of my questions was, where do you see like the biggest growth and potential use cases for this technology or industries over the next 5 years?
Sure. So I think, and thanks for your question. So I think there's been some good examples of federated in the health and finance case. What we're looking to do is actually bring this into the manufacturing space. So we're serving like energy utilities, those sort of smart and connected industries, where we're actually looking to deploy intelligence down to the edge. So if you can imagine the automotive sector, there's thousands of cars being produced every day. That makes way for this, a great use case to actually keep the intelligence on the car, where consumers might be restrictive around sharing that data. Again, across that space in energy, I touched on before, the wind turbines, where we're looking to move wind turbines further and further out to shore by being able to actually embed that intelligence in the wind turbine, restricts the need to transfer the data, and also any privacy security concerns of anyone pulling up to a turbine trying to hack it, for example. Don't want to get into the cybersecurity side, so I won't go into that too much, but those sectors that sort of listed at the start as well, very relevant.
Thanks a lot. Are there any other questions? Yes. And then I saw you.
Thanks very much. Great presentation, thank you. I was just wondering, in terms of the range of different devices, can this go on any device on the edge, or is it sort of specific to certain types of devices? Yeah,
so at the moment, a big place we're focusing on is actually the homogeneity of the devices that we can actually deploy in the portfolio. Currently, we can get that down to Linux and Arduino, but the goal is to get that down to the chip level so it can be deployed across a much wider range. So that portfolio, that base, we continue to add new devices onto that as well. I think that one of the great questions I've had as well, and the challenges around this, is the different devices in an estate. What we can do with federated learning is train a portion of that portfolio. So say if there's 60% of that portfolio is made up of Raspberry Pis or Arduinos, we can train those simultaneously and do those in batches, so it actually speeds up the process. And so again, regionally or by a different opco or business unit, we can apply that intelligence in the same way.
Fantastic. Sounds like a great tool.
Thank you.
And then there's one question in this third row. Thanks, David. Yeah, you can just pass it along.
Thank you. Hi, Madhusudan from NeuroCat. So I was just wondering, like, with federated learning as such in general, like, where do you see as still the potential for the technology to improve, and then what is currently holding it back in terms of expanding it to other domains also?
Yes, great. So again, thanks for the great question. So in terms of other domains, I think there's some really good proven use cases in health and finance, like I mentioned before. And I think it's going to be an increasing adoption around, especially where we come up to those challenges around to data access. I think the barriers to the technology, I think it's one of those ones where sometimes we're in a bit of a sort of data science bubble, and federated learning is the next level of that benefits the user, but they don't necessarily need to know sort of how it sort of works. So I think it comes down to sort of user adoption and customer readiness, and I think a big process around it. And I think there's a few discussions around it as well, as around like keeping the human in the loop. So if people are aware of how that's used and the data's being used and how you're sort of solving those challenges, the federated just becomes part of that process that needs to be delivered as well.
Okay. And do you see this being applied across complex use cases also? For example, I'm still looking forward to hear the one from automotive where this can be applied in a scalable and a reliable way. So what's your take on that?
Yeah, so I think automotive is a great example, right? So there's a lot of compute capability in the car. There's only increasing compute capabilities in the car. As the intelligence increases, we need a way to be able to reduce the connectivity and the sort of latency on those devices as well. Call them devices, assets, vehicles. So I think the automotive is a great sector to be able to apply it to, and it doesn't just benefit the vehicle or the user, it benefits the grid when we're coming into electric vehicles, it benefits the infrastructure where we're looking to charge or refuel cars as well. So I think there's an intelligent network there that can be developed in the automotive one, which is, I think, ready to be delivered and ready to mature.
Okay, thank you.
Thanks for the question.
We've got time for one last question, if there is one. Yeah, you can. There is none. So, George, thank you very much for taking your time, for sharing your insight, and also for answering the questions.
Thanks, everyone.